is the Neumann series. Carl Gottfried Neumann, 1832 to 1925. If the norm of A is less than 1, we have that A minus lambda I is just equal to what? What? How does that go? Sorry, let me write down what he says. I find that mysterious.
We have norm of A is less than the absolute value of, sorry, the modulus of lambda. Are we just plugging in, we don't put a modulus of lambda equals 1, or even actually lambda equals 1. Well, I guess so that doesn't seem to make sense.
Well, so I minus is equal to, I mean, this is if, sorry, what do you say? It says if the norm of A is less than 1, then I minus A? Oh, I minus A inverse. Oh, look, he's just making a corresponding comment based on what we're talking about. Like he's not writing it in the book. So this is reading between the lines. I don't know as he's really, I'm not so sure that that's a corollary to theorem 4.98 as much as it is a formal nonsense corollary to theorem 4.98. I mean, maybe it is though. I'm a dummy. Yeah, lambda equals to 1.
The only thing I was confused though is it was still a negative sign up front, so I did.
But you notice that it's flipped. It's I minus A.
Oh, okay.
So it's.
I didn't notice that. Okay.
So, I guess the same. Maybe it's a different proof even. Like it's like the same, but with a flipped with a minus. I don't know if I can, because I don't. Well, that's a question. If you have that CB is equal to I, right? So, and that's equal to, BC.
Yes.
So C is equal to B inverse.
Yes.
Is it the case that minus C minus B is equal to I is equal to minus B minus C? I guess it is, right? So therefore, the inverse minus C is equal to the inverse of, is minus the inverse of B.
Okay, yeah, then it's canceled, so you get what you're saying. Okay, that makes sense. Interesting.
Why have I not assigned that as a homework problem in linear? That's a nice homework problem.
Oh, yeah, that makes sense.
I mean, if a function's invertible, prove that it's the net negative of the function's also invertible, and
it's the negative of the inverse. Yeah, there you go. Nice.
that's a really simple. That'd make a nice test question if it wasn't talked about beforehand. That's exactly the kind of thing you like to put on a test. The thing that'll make people go, I couldn't get that problem, and then after they find out the answer, like, oh, jerk. No, so yeah. All right, let me see where we are in terms of time and such. Oh, I think I better stop here for today. I think you're tired. I'm tired. Yeah. We'll pick up again here. There's no shame in spending more than one day on eigenvectors and eigenvalues. So anyway, sorry if I'm moving too slow, but I'll pick up the pace again next time.